Okay, so I'll undo this little safety feature here that we invented to keep the door from pushing the trapdoor down, and put the Romex back. This has been the toughest thing. It just really is the right thing for this. So here we are right at the what was an exterior wall of the old 1897 building, the John Brierley house. John Brierley being the watermelon farmer who I guess made a small fortune selling watermelons to hungry, thirsty miners. Must have been a delicatesse item back in the day. And so this is the historic wall, and we're now entering the Skylight room. So this room, we call the Skylight room because of the round skylight that was put in by the Rolfe Institute, the previous building owner. And we augmented that with this 2-track lighting system, again, DC lighting. In the historic building where we were, we basically explored 2 different types of track lightings. One was DC and the other was AC. It's interesting because the DC system, basically because you're DC, you don't have an oscillating electromagnetic field at the light. Instead, you have a transformer. So in this case, we moved the transformers into the basement so that they'd be as far away from people as possible, because we're trying to create a low-impact, non-toxic environment in every way possible. But actually, intriguingly, there's been a lot of trouble with some of the DC systems. So, and it's a lot less expensive to buy AC track lighting. They tend to have less trouble. So kind of plus and minus on that. And then on the environmental impact side, every dollar you spend on a project is generally being produced by some damage, environmental damage. So less money usually ends up meaning less environmental impact. So in some ways, the AC lighting may be the better environmental solution. So in addition to moving the ballasts into the basement, we also have a little story about electromagnetic radiation that we discovered in this room. Peter, you want to share what you found?
Sure. At the beginning of the job, I took a gauge meter and walked around the building to see what the background radiation was. And in this room, I found an extremely low-frequency magnetic field coming up into the room. And when I went back and forth in the room, it was a long linear feature. And that's where we discovered this sub-panel wire that was buried in the slab. And that's when the discussion started about what we could do about it, because we didn't want that in the space of human use.
So we're standing here on a 4-inch slab, and there's a conduit running through that 4-inch slab, so very, very close to where people are sitting and lying down and hanging out. And that conduit is feeding the sub-panel in the basement from the main panel at the south end of the building. And so all the power for the entire office area in the historic structure was running through this floor here. In fact, I think some significant systems were being fed by this one piece of conduit. And just to recap, what we're talking about with a Gauss meter is a tool that measures, an instrument that measures the magnetic field, and we're talking usually milligauss. And in the case of a magnetic field, you're going to get a fall off of density, of field density with a square of the distance. So being very close to the source of radiation is a serious problem. And that's why this particular issue is of such concern, because the field source is literally directly underfoot, or if I'm lying down or sitting down, it's right next to me. So we have a little story about that. What we did is we rerouted the conduit. We basically broke the line, ran new conduit outside the building, up on top of a parapet wall, around, down, and into the mechanical room, doing everything we could to route the cable away from humans as much as possible. And then we had an interesting experience. After we did this, a lady came by, she's a shaman, and she had come by before we did this and determined that the room wouldn't work for her, that there was something wrong in the feeling of the room, it just wasn't going to work. She came back and said, wow, what did you do? This room is great. I can use this room. It feels really good in here. Really, the only thing we did was to reroute the conduit. We didn't put hydronic heating in this room, for instance, which was part of our remodel project. The reason we didn't do that is that we couldn't get below the floors like we could in the other building or other part of the building. We would have had to step up the floor to do a hydronic system here, and that also would have had an impact on the stairs. So it was a cost-saving measure. We could eliminate that one zone. And what we have instead is when we took out the old monster HVAC, 70% HVAC unit, and broke it down into two Sears-rated higher efficiency units, one of those units is dedicated to this room. So there's a touchscreen Honeywell control just for this room. Because people come into this room just for an hour or two at a time, we can just pump a little cool air or hot air into this room as needed, and it turns out to be a very efficient solution for this particular room. And then we're not heating it all the time. So that ends up to be a high efficiency solution for this particular room in terms of the HVAC. We did have to work a little bit on the sound isolation because we're very close to the actual unit with the ventilation here. One other point in this room would be this storage unit, which basically we built so that we'd have some room for clients to store their things. And one feature is that I broke it at the top so it doesn't feel monolithic all the way to the top, and rounded the corner here. And now we'll enter the hall.